Hello, Trevor. Hello, Mike.
Hey, guys.
Hi, Trevor. Hi, Caio.
Right. Thank you for joining us live. So are you an iOS developer?
Yes, I am professional iOS developer for about 4 years.
Awesome. How can we help you?
So going through the lessons, I especially the first few about around test-driven development. I was trying to wrap my head around a good way to like some kind of framework or like list of things to be thinking about when doing test-driven development. Like when we're doing some tests, like what do I even care about? What's important? And like when we had gone through just the communication between two objects, basically, like how when we initialize them, I wouldn't have thought to say, okay, just make sure that no work happens, or when we're calling, like double check for maybe duplicate messages being sent and stuff like that. And I just kept thinking, like, time after time, I was like, man, I wouldn't have even thought of these things. Like, and so I was just hoping to get a good overview, kind of like, just so I don't know, like a framework of like how do we start thinking about this to cover the important cases? Because maybe if I think about it myself, I could start thinking of things that maybe aren't as important and get lost in too many details. Yeah, I just want to kind of figure out what's most important and the right way to think about it. Yeah.
Okay.
Awesome.
Sounds good. I know that it's, especially when you've already been coding for a long time without TDD, it's hard to kind of get into it because it's a completely different way of thinking, pretty much, right? Thinking about the test first and driving the design and the behavior from the test point of view.
Mm-hmm.
So I get it, because I also didn't do testing in the beginning of my career, and I had to learn it afterwards and had to unlearn some things to be able to learn TDD.
Yeah.
Because the basic rules are pretty simple, right? You start red, green, factor, right? Which means you start with a failing test. Then you make the test pass. And here it's important with the minimum amount of work.
Yeah, in watching the videos, like it was so, I guess I'm sort of a global learner, like where I want to see the whole thing kind of, and that, I guess that makes it hard for me. Like I want to get it all done, first try, first shot, everything's working. And like when you would do a test and say, okay, like we're going to check that this 200, if it's a 200, it passes. And, or if the JSON is valid, it passes. And it almost seemed like these shortcuts where like the test was passing, but it wasn't covering all the cases of like real life. Like, but then eventually got there. So by the end, I was kind of like understanding, okay, like I see where it's going, but from the beginning, it was hard to be like, to accept that like we're just doing the minimum amount of work, to get just the test passing. But then it started to make sense. Like once we have enough tests, like we keep adding tests, then that starts covering other cases. I guess that's a new way of thinking for me. So
yes, absolutely. For example, as you mentioned, you're getting a response from the server, like an HTTP response. It has a status code, right?
Mm-hmm.
And you want to test that when you get a 200 status code, something happens. But this status code is represented as an integer. And this integer can be any number. It could be 0, it could be minus 317, it could be, different results, but you care about 200. But you need to write tests. What if it's not 200? Right? So you need to have at least one test when it's 200 and when it's not 200. Right? You need to have the
right.
when the behavior is what you expect and when it's not what you expect.
Exactly. And by default, like you're probably gonna think just the behaviors that you want to happen. Like this is the first thing that comes to mind. Yeah. So this is important to understand. Like I'm programmed this way. I'm wired this way. So I need to anticipate for the things that I don't want to happen, but I want my system to be able to react to them, appropriately, right? So in this sense, it's kind of a hedge as well. Like having these tests there, they protect your code and your system.
Especially when you're dealing with a range of things, right? For example, if you say, no, any 200 to 299 is valid. Now, how many tests do you need? If you're only testing like 200 Ks, you need 2 tests. One when it's 200, when it's not 200, right? It could be anything that is not 200. But if you're testing a range of things, you need to test when it's 200, when it's 299, when it's a number in between, 150.
Mm-hmm.
You also need to test the error cases when it's 150, 199, and let's say 300. I would add at least these 3 tests for the error cases and at least 3 tests for the success cases.
Yeah. Okay. Like at certain points I was wondering, like, are we testing how much of like Apple's frameworks are we testing? Like Foundation, like do I need to test every single 200 number, like anything in the range, or just like these 3, I just had these kind of questions. I'm glad you brought that up.
Yeah, you don't need to test every number from 200 to 299. You need enough samples to give you confidence. It's all about confidence, right?
Yeah.
When you have enough confidence that like, okay, I covered the minimal boundary, right?
Mm-hmm.
And the max boundary and something in between in the success case. I'm confident the success case is covered with these 3 samples. Another thing you can do is to use random numbers from 200 to 299 as well, which may increase the coverage.
Yeah.
But I want to have hard-coded at least these 3 here. Why? Because there's often always the off by 1 error when by mistake you put something like this, and you don't include the 299, or by mistake you do something like this because you think that it's not going to include 300, but it does, right? So I think those are important to have fixed in there, and then you can have a random number in between as well, getting random data for the test. But you don't need to test all the numbers in the range. That's enough samples to give you confidence. And you can have some hard-coded samples and some random samples to make sure that you have good coverage. And in the error case, you also need something very close to 200, the 199, one before, and 300 to make sure you don't have off by 1 errors. Right? And for example, when you're testing a list, it's important to test that 0 case when the list is empty, when the list has 1, and one has many. Now we're talking about guidelines and patterns, right? And how you would learn these guidelines in practice and patterns, practicing.
Yeah.
Reading books, taking courses as you're doing. You're going to see a bunch of examples, and you need to practice. And this is going to become second nature at some point. You will know that, I'm dealing with a list, 0, 1, many. I'm dealing with a range. I'm going to make sure that I include the upper boundary, the lower boundary, the upper boundary, and something in between. Right? So this will come with time as you study, as you practice, and you apply at work.
Exactly. Yeah.
And the shortcut to this is to learn from people that made all the mistakes already, learned it, and share with others. That's the shortcut,
Exactly.
That makes sense. Yeah. Are there any other? Oh, go ahead.
Yeah, just one thing I would say here is like become aware of these guidelines and these practices. Like exactly like this 0, 1, many. It's like triangulating. Your scenario. So you become aware of such a technique, but then of course you need to practice and practice and practice so you can apply it in any case, right? Not just with status codes or a list, but make it as just part of your flow.
Right. Yeah.
For example, if you're testing a communication between two objects and you want to make sure that they are sending the messages correctly when they need to be sent. So if it's one object sending one message to another object, you need to test the case where you shouldn't have sent the message, when you should have sent the message, and how many times you should have sent the message, right?
Yeah.
Should have sent only once? Should have sent it twice, 3 times? It's important to know, because if you call, for example, a network request more than once, you're making work, doing work that you shouldn't, probably, right? You're using resources that you shouldn't. If you're querying something from the database too many times as well, you're going to have performance issues. Resource is going to use a lot of battery, you can, depending on the performance constraints you have in your application, you need to test this as well.
Yeah, that makes sense.
Exactly.
So this is like overall like guidelines when testing, like ranges, message sending, lists, but there are also guidelines of what is desired of a unit test. I recommend this one, this list here, by Kent Beck.
Okay. I'm not sure if I've seen that link. Was that in the lesson somewhere, or?
No,
No,
it's not in there.
Okay.
I can share that in the community.
Yeah.
But it's a good list of like desired traits a test should have. For example, should be isolated. So they should return the same results regardless of the order in which they are run. Some tests that they pass in isolation, but if you run them in the whole suite at the same time, it fails. You don't want that. It should run on its own. It should run as part of a suite, and it should run in any order. That's why the first thing we do in the program is to set random order for the tests, because if they start failing randomly, you want to fix them as soon as possible. So they need to be isolated. One test should not interfere in the result of another test, which means they can run in any order, they can run in isolation on its own, and they don't interact and don't interfere with each other. They don't leave side effects in the system.
Yeah, that makes sense.
Right, they should be composable, fast, reliable, about confidence, inspire confidence, which means if they are passing, if the test pass, people are happy to ship the code, like, yes, I trust this test. The worst thing you can do is like to be writing tests, spending time writing tests, doing all the work, and at the end of the day, you don't trust them. So what is the point?
Yeah, I feel like I'm still there because I don't know, like, am I covering the things I should be, like, especially when it comes to maybe like an integration type thing or the UI. I haven't gotten that far in the last yet. But
yeah, and how do you build confidence? By following red, green refactor. You always start with a failing test, and you make the minimum possible just to make the test pass. Then you refactor, remove the application, improve the design, and so on. And then you go to another failing test, make it pass. Because if you're test driving, every line of code was written with a test in place to guarantee that it's doing the right thing. Now, if you write the test after the fact, it's more likely you have gaps in there. Lack of coverage in parts of the code.
Yeah.
But if you're writing the failing test first, and you're just making the minimum to make the test pass, you will have more coverage. You have more confidence. And it's not about a number, right? Because you can have like 100% coverage and still not be confident. So we should aim to 100%, as close as possible to 100%, but with confidence. The most important thing is confidence. That if this test passes, we know that the system does what's supposed to do. Which is part of the inspiring. I would call this reliable, but
yeah.
Tests should be cheap to write relative to the cost of the code being tested. So it should be easy to write the test, which means you need to have a design that facilitates the testing. It makes it cheap.
Oh yeah, you don't have to like have all these multiple modules pulled in, all these dependencies. Like it's just easy to write a new test. Yeah.
Yes, absolutely. Because if they're expensive, you're gonna lose value, right? They should be cheap to write, which means you will make decisions sometimes. You will make design decisions sometimes to facilitate testing. And people say, "Oh, I don't want to change my design just to make it testable." Well, but this is to make the test cheap. So there is like an underlying trait we are trying to achieve by changing a little bit the design to make the code more testable. It will make the test cheaper. It will make the whole development process cheaper and easier. So it should be easy to write these tests and cheap.
Yeah. 1 second, going back to the composable, I'm not sure I understood exactly what that was getting at.
Sorry, the composable?
The composable, yeah. What, like, test different dimensions of variability? I'm curious kind of what exactly that means. Like,
yeah.
Like, is it just you can run them in any order, kind of like the first, or?
No, I don't think so. But
composable, it means that you should be able to test each part of the behavior in isolation, and that should give you the coverage that you want. You don't, instead of having to run the whole behavior in one single test.
Oh, okay.
You can break it down, and little by little.
Pinpoint, where it went wrong. Okay.
Just a side note, like every link in this document, it goes to a video
on YouTube for free with the explanation.
Exactly. They explain what each trait there. I mean, it's in Ruby, but whatever. It's like very easy to follow.
Yeah. And this is that link that you showed me before.
Yes. Yes.
Okay. Cool.
All right. Where were we? Readable, behavioral. Test should be sensitive to changes in the behavior of the code under test. So if the behavior changes, if you change the behavior in production, the test should fail, right? It should reflect in the result of the test. So if the behavior changes, you want to see a failing test because the test should be testing the behavior. But it should be decoupled from the structure, which means you should be able to refactor your code, change the structure, change the design without breaking the tests. This makes the test cheap to maintain. Because, one of the concerns people have is like, okay, I write all these tests and then I need to change my code, 100 tests fails. Well, because you're not following these desired traits, right? And it's not easy to achieve this, but there are techniques, there are design techniques, there are testing techniques, there are guidelines and patterns that will allow you to achieve those desired traits. And you need to change the way you develop your code to be able to achieve those traits. And when you do, the tests are cheap to create.
Just say all these are in the program, like you're going to learn all this.
Yeah. The structure insensitive, like, is that where, like, it's good to test like the public APIs because then it doesn't care what's going on behind the scenes. Like it just input, output, and it's happy that they don't change.
Exactly. That's an example of that. Yes.
Yeah, that's why we say we should avoid using a testable, even like internal things. Try to hide it from the test and test through the public interfaces as much as you can. Sometimes you cannot, but that's fine. Just know that when you violate, you might lose some of the benefits here. Some of the traits you want. Next, automated, of course. Should be able to run them automatically. It should be specific. If a test fails, you should know what the problem is. You don't need to debug. You need to set breakpoints and try to figure out what's going on.
Yeah, that makes sense.
Exactly. So getting good feedback.
Yeah, so you need to create good assertions with good assertion messages in a way that it's going to say, if it fails, you know exactly why it failed.
Yeah, I was just doing a lesson on testing the, it was just I can't remember the name. but like testing the public interface of the feed loader, and it talked about like using the public API, but how that's kind of a trade-off, like not actually testing the communication between the objects, or like the collaborator that we don't really know about. I haven't gotten farther. I don't know if you eventually do refactor it and say like, maybe there was a problem and we want to test the collaborator as well. Like, what would that, I don't know if that's too in depth for this, but like, what would that look like, I guess? Would you have overlapping tests? You have like the higher level public API, kind of like integration tests, and then another one for parts inside of that to help you pinpoint things easier.
Yes, absolutely. So when you are writing unit tests, usually you want to test them in isolation. Or you want to test your components in isolation.
Mm-hmm.
But there are other testing strategies. So unit tests are usually called unit tests or isolated tests, because it's about testing things on its own, separated from other components, other modules. But you also have integration tests. You have snapshot tests, UI tests, tests, acceptance tests. There are many strategies you will use depending on what you're trying to test, what you're trying to achieve. And you need a little bit of each one of those here in your application. But the majority of tests should be here. Why? Because unit tests, good unit tests, have all those traits. But if you go here, snapshot tests, UI tests, integration tests, they are not as fast.
Yeah.
They're not as inspiring. They're not as cheap.
Yeah.
You know?
Yeah.
So that's why if you look at the pyramid of tests, they say like the base of the pyramid is unit tests. Most of your tests should be here because of those traits they can have. But doesn't mean by writing a unit test, they have these traits. You need to aim to achieve those traits. You need to learn the patterns, guidelines, and design your system in a way to allow all of this. And it's all there in the program. So in the program, we focus on teaching the unit tests for you to build the solid foundation of your testing strategy here. Then we teach you how to use integration tests to check the collaboration of components. We also show snapshot tests and UI tests to check the UI side, how things look, the actual visuals. And at the end, acceptance tests, putting everything together and testing a feature with a higher level test.
Yeah. What is that, like another UI test, or what do those look like?
Acceptance tests.
Mm-hmm.
They can be tested through the UI.
Yeah, they could be
black box tests. I avoid that because it makes them much slower. I do it through code. Let me show that in the program. How to do with UI tests or with integration-like tests. They're much faster, much more reliable. And you can control the infrastructure details as well, so you don't actually need to make network requests. We also show end-to-end tests.
Yeah.
That's like the communication with the app with a backend, for example, or the app with a database or the file system, and so on.
Multiple integrations.
So those are strategies. Strategies. Yes. So you will learn strategies, guidelines, patterns, and you should go through this loop. Learn concepts, see examples of those things, and practice. And it's all there in the program.
Yeah.
But again, the foundation, your primary testing strategy is this one, which is cheap, fast, inspiring, readable, fast, composable, isolated, automated, specific. Where were we? Deterministic.
Yeah.
So running the tests, if nothing changed, it should always pass or should always fail. If there's a problem, it should always fail. If they are passing, it should always pass.
Yeah. Does that kind of infer, like make maybe random tests that throw random numbers out would be confusing maybe sometimes if around like you have this range and a random numbers, like it's not the same every time. So deterministic, it's not as deterministic. I don't know like how that relates to.
It depends. You can use random samples, as we said here, as long as you have a good sample generator that's going to obey the rules or the properties you want for that test. For example, I'm testing the boundaries 200 to 299, and I'm generating random numbers between these things. Then the test should always pass, right? And there are property testing is another strategy.
Yeah, that's another strategy. Exactly. It's called property testing.
Which is part of unit testing as well.
Yeah.
Property testing, where we define properties you want for your components. Like it should always work with data from 200 to 299. And you set these properties in there, and it will automatically generate random values meeting those properties you expect. And the test should never fail. Right? Even though the results are random, they're within the boundaries you expect your test to be. And then you can run your test like 1,000 times with random values, and it should pass 1,000 times.
Yeah.
Because it obeys the properties, right? That's the main idea. And you generate the sample data randomly. And if it fails, it's going to tell you exactly, oh, it failed with this input. And if you fail with a specific input and you run again with that specific input, it should fail again. If it passes sometimes, it doesn't pass other times, you don't have a good unit test or isolated test, right? And when does this happen? UI test, for example. Because sometimes when you run a UI test, it needs to connect with the app that is running and find an element on screen, but then there's a timeout somewhere in the XPC server that is connecting with the simulator or the device, and there's something completely unrelated to your test that breaks. Or you make an end-to-end test that will communicate with a backend API, but the connection dropped somewhere. The router, failed for a second, or the server was down. Like, they are not deterministic because you can run the same test twice. Sometimes it fails, sometimes it passes, because they depend on systems outside the scope, on side effects outside your test. So they don't have this desired trait of being deterministic.
Yeah. Okay, that makes sense.
That's why you shouldn't rely that much on those kinds of tests.
So they're called flaky tests as well.
Yeah. Heard that a lot at work. Yeah.
You can make your acceptance tests be reliable as long as they don't go through the UI.
Yeah, absolutely.
But those two are flaky in nature.
Yeah. So acceptance tests, is that kind of like related to the story, like the acceptance criteria? Is that what that's referring to? Okay.
Yes. So you would define the acceptance criteria with the stakeholders, with the business analysts, and you will have high-level tests checking that acceptance criteria is met.
Okay.
So there are high-level tests, and those are low-level tests.
Like at the component level is what we mean. Low level this is at the component level, right? Like a function or a class, a struct, something like that.
There you go. Predictive, the last one. If all the tests pass, you should be happy to ship the code to production.
Exactly.
No, if you run Command U, all the tests pass, you send it to the App Store automatically. No ceremonies,
No, yeah.
We also show that in the program to set up the whole pipeline for continuous deployment and continuous delivery.
Cool.
So you push the code to GitHub, it's going to run the CI pipeline, run all the tests super fast. If everything's fine, it's going to upload the binaries to the App Store, and that's it. Automatic, no human intervention.
Yeah. Sweet. Can't wait to get farther into the course.
No, and this will come with time.
Yeah.
The more you practice, do the challenges as well. All the challenges have tests.
Exactly. So make sure you go through the challenges,
Mm-hmm.
you know, see them, you know, to see how, like, this practice in action. So yeah, and it's gonna take some time, but
it all starts here. Red, green, refactor. Start following these rules
Mm-hmm.
and aiming to achieve those traits. And in the beginning, you won't be able. You will violate a bunch of those traits because it's part of the learning process. That no one's perfect when they start, right? And we are always we are always constantly like reading new books, learning new techniques, new guidelines and patterns to be as close as possible to those traits.
yeah,
You know,
exactly. In languages like Ruby, you know, in languages like Java,
yeah,
like
exactly. We learn from different platforms, from different authors,
Mm-hmm.
as much as you can, and focus on finding solution that meet this. So when you're reading an article from someone saying, "No, you should write tests like this," and say, "Okay, does it meet those criteria here?" Because I recommend, and that's the guidelines that I follow. This is what I try to achieve with my tests. Those are the traits I try to achieve with my tests. Not everyone follow this. So people are looking more for convenience rather than the traits that will make them more valuable. So it depends what you're trying to achieve. I recommend you follow these guidelines.
Okay.
But it's up to you and your team, right? This is a decision. It's not just your decision, but if you're working in a team of people, you all should be aiming to achieve the same goals. Otherwise, there'll be a lot of conflict.
That's true.
Right? Because you make a decision and say, "Oh, I'm making this decision to make the test fast," and people are like, "Oh, I don't care if the test is slow. I care that the test is convenient," or something like that, you know.
Yeah.
And then you have conflicts. But as long as you share the same desire to achieve the same traits, the same goals, no conflicts. Everyone will be aiming to achieve the same thing. So during a review, in a pull request, in a merge request, you can say, when you give a comment, say, "Hey, I think if you do this, we can achieve that trait that we want of making it fast or making it inspiring or making it writable,"
Mm-hmm.
and so on. It's easier to communicate with them because you have a language, you have specific or clear goals of what you want to achieve with your tests in the code base. And that's a team exercise to keep reiterating what we want to achieve. What are the traits? You know, set the bar high.
yes.
You know, that's the point.
Yeah. Yeah. Cool.
And it's not easy to achieve those traits. It's not like, "Oh, I read these and I know what I have to do." No, years of practicing.
Yeah. Yeah. It's like lots of remembering just different scenarios and having done it enough to be like, "Oh yeah, like I remember like this will help me in one of these areas." So lots of practice.
yeah, and
I can
just
see it.
don't wait also, you know, for the work project to present an opportunity to
Mm-hmm.
practice these things, you know. Like, I suggest, you know, you practice on some side projects, start practicing on side projects and in the academy as well, you know, doing the challenges, this sort of thing, you know, because at work is going to be very hard, you know. Like, you probably are working with the high pace, you know, shipping all the time, stuff like that.
Deadlines, schedules,
Yeah.
you know, meetings. Like, it's going to be hard to find the time to actually practice.
Yeah, and it can be a bottleneck, you know. Like, it's a practice that you're not good at the moment, you know. You're, of course, you're striving at, but at the moment you're just not that fast. So that can be a bottleneck for the whole development process. So how do you bypass that? You know, practicing with side projects. That's it.
Mm.
Yeah, I like
Yeah.
to think it's like this. If you're a musician, you don't practice on the stage, right? You practice before the gig, and you show up in the gig prepared, and you just perform. It's the same thing. Or if you're a UFC fighter, you're not gonna practice in a ring, right? In the octagon.
Yeah.
That's not a good
true.
idea.
Exactly.
So yeah, I had to practice many of those techniques and like guidelines and patterns outside work because many times I didn't have the time to practice at work.
Yeah, but it's a fantastic investment. It's like it's gonna pay off big time once you're able to do these things. Because it's a trait. It's a scarce trait in the industry, and like you need it if you want to create great stuff. Great products. You just need the security that automated testing offers. So
yeah, because this is just the foundation for enabling automation in general and continuous delivery. Right, you start with the testing, then you have automation in the continuous integration, so you can speed up development in group, in a team. Then on top of that, you put continuous delivery, continuous deployment, and then you can start developing and delivering your app, new versions of your app, like every week, every 2 weeks, whatever makes sense, rather than every 6 months or every year, or you can be much more competitive. Yeah. So if you have those skills and you can help businesses be more competitive, I think you have a good time.
Big time. Yes.
Makes sense?
Cool.
And regarding like implementation, because you're talking about concepts here, right?
Yeah.
Now, examples, you see that in the program.
Yeah.
Like hundreds and hundreds of tests and examples in there of all strategies.
Literally.
And you can even practice there with the challenges. So don't just watch the videos, but actually put it into practice. Write the code.
Yeah, that's what I haven't gotten to yet, is the challenges, like the first one. But I'm looking forward to it because I've been thinking about it, and like at work, I'm like, I just don't know where to start. Like you said, like it's going to take me too long. On my side projects, like I think I need to start even smaller. So I think I'll be looking at the challenges and then take that to the side projects, and then eventually to the main work job. So
absolutely. I mean, you can even start just like literally typing what you see in the program, right? Like having your Xcode screen split, and having like the tests on the left and the production side on the right. This is on its own, it puts you into this, I don't know, like mode, like this testing mode, and it's just part of the process. It's gonna make you follow the steps, the whole flow, the testing flow. So don't underestimate that. Even if you have to type what you see in the video, like not copy and paste, just actually type, so you can go through the motion and the steps. Yeah,
because sometimes you see the video and you're like, okay, I know how this works. And then you try to do it on Xcode. And then you try to hit Command U and nothing happens. You're like, what? And then you need to learn how to set up the test scheme.
Yes.
And the test target and so on. And then it's going to start learning things behind the scenes. Just like trying to learn how to swim just by watching a video. Until you actually go into the water, you're not going to feel what it's like to be like floating in there. It's the same thing. You're going to miss some details by just watching the video. You miss important details that you only get by practicing, by putting it into action. Right, so that's why it's important. And even like if you don't know how to start, just type exactly what you see in the program, just to get into motion.
Yeah.
And you get there, one step at a time, and repeat continuously.
Yes.
Also check the book suggestions.
Okay, I don't think I had seen that yet.
There's a bunch of books there, also about TDD, about architecture, design in general, about personal development as well, leadership. Check it out. It's important to be reading all the time, learning new things. Was it helpful?
Cool. That was very helpful. Yeah. I'm glad that you guys took the time to talk with me and kind of walk through a few things. And answer some questions. So I really appreciate it.
Absolutely. Thank you. Thank you so much for coming here, joining us.
Yeah.
Awesome. And also sharing with others. It's going to help a lot of people as well. They have the same questions.
Yeah, hopefully.
Awesome. Thank you.
Thank you so much. Thank you so much, Trevor. Take care.
Thanks, guys. You too.
Bye.
We'll see you.
Bye.